So let's talk about equality of matrices. So let's say there is a matrix A and there is another matrix B, and A is equal to B if and only if. So that's two ifs. If and only if condition 1, that is A and B has the same size. A and B, sorry, have the same size. Have the same size. And by size, what I mean to say is that A and B have the same number of rows and columns. And second condition is that the corresponding elements are equal. So the corresponding elements are equal. Again, by corresponding elements, what I mean to say is that the element in the ith row and jth column of A needs to be equal to the element in the ith row and jth column of B. Okay, so let's this is too abstract, so let's actually just try to work it out with few examples. So let's say if A is equal to A1, A2, A3, A4, A5, A6, all right, and let's say B is equal to B1, B2, B3, and B4, B5, and B6, right? So first of all, if A and B have to be equal, they need to have the same size, which indeed is the case, right? So in this case, so A is a 2 by 3 matrix, 2 rows and 3 columns, and so is B. It's also a 2 by 3 matrix, so this is check. Now if A and B have to be equal, right, so their corresponding elements need to be equal. So A1 needs to be equal to B1, A2 needs to be equal to B2, and so on and so forth. So A1 has to be equal to A2, A1 has to be equal to B1. A1 has to be equal to B1, A2 has to be equal to B2, and so on and so forth. All right. So let's next talk about the addition of matrices. So let's talk about addition. And you can only add, first of all, you can only add matrices of equal sizes. So that is two matrices that have the same number of rows and columns. Okay. So let's say if A is denoted by, let's say, Aij. Okay. And let's say the matrix B is, let's say, denoted by Bij. Then the matrix C, which is, say, the sum of A plus B, will be denoted by Aij plus Bij. So essentially what this funny looking statement is telling us that the element at the ith row and the jth column of C is the sum of the ith row and jth column of A and B. Okay, so for example, so let's say A be a 2 by 3 matrix. Okay, so let's say A is equal to, let's say 1, -1, 0, and let's say 2, 4, 5. Okay, and let's say B also be a 2 by 3 matrix. So let's say B is equal to, let's say, 2, 5, 1, and 7, 6, 4. Okay, so now if we were to define C, which is the sum of, let's say, A plus B, so C will be equal to the sum of its corresponding elements, right? So this, the first element of C, that is the element at the first row and the first column, will be the sum of the element at the first row and the first column of A and the first row and the first column of B. So this will be 1 plus 2, right? And so on and so forth. So -1 plus 5, first row, second column. So the first row, second column of C will be -1 plus 5. Okay. The first row, third column, 0. First row, third column, 1. So 0 plus 1 will be the value of the element at the first row, third column of C. And I think you get the pattern here, right? How do we actually add matrices? So this guy will be 2 plus 7. The next element would be 4 plus 6. And the last element here will be 5 plus 4, right? So this becomes 5 plus 4. So this finally becomes 3, 4, 1, 9, 10, 9. All right. So this is A plus B. So we also have a concept of additive identity. And let's in matrix addition, and let's define it by a zero matrix. So a zero matrix is defined by 0, which is boldened. All right. And a zero matrix with with a bold 0, let's say its dimensions be m by n. So it's such a matrix which has m rows and n columns, and all its elements are zeros. So you have 0, 0, 0, 0, 0, 0. So this has got m rows and n columns, and all the elements are 0. Okay. So now if A also be an m by n matrix, so this also be an m by n matrix, right? So now if A, you can check it out. So A plus the 0 matrix, which also has m by n dimensions, will be equal to the 0 matrix plus A, and that will be equal to A. It's kind of like the additive identity in normal algebra, right? If A is a scalar and 0 is actually a scalar, 0 is a number. So A plus 0 will be 0 plus A equal to A. So that's what we have here for matrix addition also, if you consider 0 to be the 0 matrix. Okay. All right. So let's finally talk about scalar multiplication of a matrix. So let's say C is a scalar, okay, and A be a matrix of the form Aij. Then C into A will also be another matrix with exactly the same size as that of A, and CA will be equal to C times Aij. So essentially all this means is that this funny looking statement, it means that all the elements of A will be multiplied by the scalar. So let's say A is equal to 1, 2, 2, 3, 5, 6, okay. And so in that case, let's say if we were to multiply A with 2, so 2 times A will be equal to 2 into 1, 2 into 2, 2 into 2, 2 into 3, 2 into 5, and 2 into 6. So we are just multiplying 2 to all the elements of A. So this results in the following matrix: 2, 4, 4, 6, 10, 12.